All right, good evening, everybody. Can those of you online hear me okay?
Yep.
Yes. Works good.
All right. It is time to get started. So thanks everybody for joining. We got a dozen people in the room and a little over a dozen people online. So great to see everybody here. We'll get started with the pledge. So all in the room, please rise, remove your covers, at home, whatever, and we'll join me in the pledge. I pledge allegiance to the flag of the United States of
United
America,
States of America,
the republic
for the
for which it
republic
stands,
which is
one nation,
one nation, under God, indivisible, with liberty and justice for all.
All right, you may be seated. I'm sporting my swag that I keep talking about and keep failing to put the link in the scope. So I've emailed scope just now to remind us to get the link in the template so that it's there every time we have a newsletter come out. All right. Anybody first time visitors? Well, I guess we'll go ahead and have Bob introduce yourself since you're the first time joining us, even though you're going to be our presenter.
Hi, Bob Strickland, N5BRG here in North Texas, EM13.
Thank you, Bob. Any other first time visitors with us for the meeting? What's your name, call sign, location?
Roger, W6CDA.
Roger, W6CDA from CVA, Charlie Victor Alpha from Carlsbad. Short commute for you. All right, welcome. Glad to have you here. Anybody do a license upgrade recently? No?
NISCD.
Oh, congrats. So up to extra then.
No, just general.
No?
I've been a technician
just
for
general.
20 years. But,
Okay, well, congratulations. Fantastic. Any other license upgrades? No? Okay.
You have one on the Zoom who's just puts his name as Bill, no call sign. I don't know if he's new or if he's just hiding.
Oh yeah, I see that. Bill with no video and audio.
I'm just hiding, yes.
Okay.
From San Diego. Thanks.
Okay. If you wouldn't mind adding your call sign, if you have one, that way we can properly get
Okay.
attendance
I'll do that.
credit wise. And same thing for Alan. And Keith, I guess we know who you are, but if you are able to switch it up so we have your call sign, and then I guess my call sign went away too. The internet here is not great. Okay. Announcements. If I could have our nominating chair come up and we will get that business out of the way. There it is.
So I have polled the existing members of the board, seeing if we could put together a nominating group for the December election. And fortunately, everyone has offered to serve again another year. So Joe has volunteered to serve as president, K6 JPE, Chris as vice president, KD9 LF. Jim will be our secretary, or offering to run as secretary again, W6TQS. Jim is treasurer, F2VO. Ron as director number 1, AJ6FQ, and John as director number 2, W6XM. That will be the slate that will be put forward for the election process in December.
Great, thank you. All right. Any questions or comments on the nominating committee and the slate? All right, we will vote on that next month. Other announcements as we're in the scope, not quite ham radio related, but because we work so closely with the emergency services, the Oceanside Fire Department Honor Guard is having a flag retirement ceremony at their Fire Training Center, 110 Jones Road, on the November 12th, Saturday from 10 to noon. And if you haven't been to if you haven't been to a flag retirement ceremony, I highly recommend it. It's very moving experience, very respectful way to dispose of tattered flags. For more information on that, see the scope. Check out the scope for a video of the race cars going up Palomar Mountain South Grade. It was, I wasn't there in person, but the video makes it look really cool. And they had ham radio operators stationed around at different checkpoints to make sure everybody was making it up the hill and didn't have an accident or medical emergency or other emergency. They had the road closed to public traffic and reserved for the racers. So that was a great event. I heard good things about it, and I heard that the amateur radio operators had a great time as well. They have another one coming up on Saturday, December 3rd. So there's contact info in the scope if you want to volunteer for that. And let's see. If you have pictures of anything that you've been working on, or if you've visited any events like the Move truck or anything else, please send those to the scope at palomararc.org so they can get into the newsletter. John has something to talk about, right? You have all right, I'll come down there. Grab both of those.
Both of those. Okay. Is this for stereo?
One of them goes to here.
I know, I'm
one goes
joking.
there.
Okay. I've got a Tektronix 492P spectrum analyzer in the car. I was hoping to find a new home for it. So it's not in working condition. It needs help. And I got tired of looking for help. I would have no parts for it. If I had a second one, I could steal parts from it to try to make them work. But to be honest, I don't like Tektronix spectrum analyzers. I like HP spectrum analyzers much better. So if you're interested, give me a contact, and it's in the trunk of the car, and it's a donation. Yeah, it's a donation to the club. Whatever money I get for it, I'm asking $150. So that's about a third of the price of the eBay prices for the things as is.
Okay.
You
All
should
right.
note, John, excuse me, John, you should note that that spectrum analyzer was in use 3 weeks ago. There was a loud pop from the high voltage power supply, and it stopped. So it is, there's hope for it. And it's a 21 gigahertz spectrum analyzer. So it's not a schlock instrument.
Okay. Good deal. All right. Let's see.
And Joe, you were
Yes, sir.
asking about projects.
Yes.
This is the offset attenuator kit for tea hunting. I built it today. I'm sitting at my lab bench.
Cool. All right. Well,
I'll
actually
bring it
brings
to
us
the next-
to.
I'll
So
bring it
Mark,
to
that
the
actually
next
brings
meeting.
us to the committee reports. So Mark, that's you for technical. So go ahead.
Oh, okay. Well, this was something that I'm just going to bring to the next meeting. I'm going to do the advertisement first. The next meeting is the Christmas social. And not only is it the social event where everybody gets to sit around and talk, but it's also those of us who have some test equipment are going to bring the equipment just like we did for the summer. And we'll do impedance measurements, SWR measurements, bring your antennas, bring your radios. I've got my power analyzer. And we will bring the repeater back again so that people can watch a fusion repeater in action. So come one, come all, bring your toys and bring your manuals. Joe, are you gonna try and bring a copy of Chirp? You're gonna try and do programming this time?
Yes, I will bring
All right,
Chirp,
so-
and let's work together between now and then to make sure we have a good file, because I think the last file was from nearly a decade ago.
Ah, okay, well, I've got one.
Things may have
Anyway,
changed.
okay, now, as far as up on the mountain, Glenn and I just went up the mountain last week. And if you guys remember the old days when window screen for houses was made out of aluminum mesh, one of the mice actually ate all the way through the aluminum mesh window screen to get into the battery building and left us little gifts all over the place. So I vacuumed it, then Glenn went through and vacuumed it, and I brought up chicken wire, welded chicken wire, and put it over all of the mesh entrances to the battery building. Repeaters are all functioning the way they're supposed to. The Hispanic Amateur Radio Society, their 220 repeater went off the air for some reason. It appears like, I did some diagnostics on it. It appears like their linear has gone flat. And so they're going up to get it because it's all under warranty still. So if you're looking at the, what is it, 223.3
238.
something.
238 maybe?
Yeah, that's it. It's not there right now. They're having problems with it. They should be back in a few weeks. That's the condition of the mountain. And it's supposed to snow there tomorrow morning.
Wow.
Mark,
Okay.
Yes.
Mark, can we make a
Yes.
quick announcement about Digi the 5? the
Oh,
07 the 5?
absolutely. Go ahead, John.
Yeah, just as a reminder, because Mark and Glenn are on the screen and Charlie and I, we still get together at 5 o'clock. We call it Digi the 075 at 5. And we're there every day, 7 days a week. It's about 10, 15 minutes. We say hello, see the latest thing we're doing. We get visitors who drop by from time to time. We log them in. So some people who do have Yaesu radios, all you have to do is touch your mode button and go over to DN and pop in at 5 o'clock. And we're always glad to have you come in to say, we call it Digi the 075 at 5. So come on down and keep us alive.
All right.
Just one quick comment for those who aren't used to it. That is C4 FM. That's the digital mode of the Fusion repeaters. And if you don't have a Fusion repeater, it sounds like the old days with modems. Lots of screaming. But we'll be there, and all the Yaesus can operate it. So come join us.
All right. Great. I don't see Charlie. Does anybody have an update on the grant request?
Well, I was part of it yesterday, and at last position, we'd pretty much completed all of the request information, and Charlie was due to submit the second round grant today. Don't know if that happened. I will assume it did.
Okay. And then Mark, we had an offer from in the room about a cabinet for storing some of this stuff, a rack. I don't know if we have space, but he's going to email board so we can know what we have available if we need anything else. All right, let's see, membership, Glenn.
Okay, well, we have 150 members registered on per the website, and I have about 5 things to process. I believe 2 of them are brand new members, and I don't have their names in front of me, so possibly we have 155. One question: did anyone see my my note in the scope for this month's scope? Looking for ambassadors. I tell a little story about when I joined the club the first time and didn't come back for a year. And as I was going through sending out reminder notices, I realized how many new members that were new last year, and I'm sending out the first renewal request and wondering, gee, I hope their first year in the club was not like mine. So I'm looking for people that are willing to just be a contact point. You don't have to be an Elmer to them per se, but be a face that they can reach out to and stay connected and get connected with the club. So see the scope and act accordingly. Thank you.
Okay. Sorry about that. My cellular decided to disconnect. All right. I'm going to assume Glenn finished.
Yes, I did.
Okay.
See the
All right.
scope, see the scope. If you didn't
Okay.
hear me.
All right. Any other questions, comments from the group here or from the group online?
I have something.
Okay, go ahead, Joe.
I was contacted by somebody whose license had expired, and she didn't realize it had been expired for 1.5 years. It's 10 years is a long time, and you may not realize your license is due to be renewed. So my recommendation is to look occasionally and see what year it needs to be renewed, and keep an eye on that, because for her it was a complete surprise that she had she was 1.5 years overdue for renewing her license, and she was still happily going along talking on the radio.
That is a great reminder, Joe, and maybe that's something we should do a little blurb about in the scope every once in a while to say, hey, maybe every year, every January or something, or February around the club's anniversary, do a reminder to check your license expiration. That's a good comment, Joe. Thank you for that.
Suggestion. I just had to renew mine after the 10-year mark, and it was because it was on my computer calendar. And so I just moved another copy of it to 10 years from now, and I'm ready. So that's a suggestion. People get it on your electronic calendaring.
Yeah, I think mine's on my Google Calendar. So, yep. Okay. Let's see. Yep, I guess that's it. Okay, your board currently is Mark, KF6WTN is your repeater text check chair who you heard from. Keith, KM6CXW is your scope editor that we see here. He would love to have articles. Please send them to scope@palomararc.org. Chris, KD9LF is one of your directors. Ron, AJ6FQ is your other director. Glenn, AI6RR is your membership chair. Jim, K2VO is your treasurer. Other Jim, W6TQS is your secretary. Charlie, NN3, wait, I think I have these. I think this is an old copy. Sorry, Chris, KD9LF is vice president. John, W6XM is your other director. And I'm Joe, K6JPE, your president. And now we will turn it over to Bob, your presenter for the evening. You should be able to present, Bob. I've already made you a co-host.
Okay, great. Thank you very much. Well, it sounds like you guys have a really fun group here, and and I've enjoyed being here already. Feel pretty comfortable. I've got a bunch of slides here about radio astronomy, and I want to see if I can get through them. I've got so many, we may have to leave some off, but hopefully not. If you have any questions, well, just go ahead and try to interrupt me and let me know. And also, I'll be trying to keep an eye on the chat window over here on the side as well. It's funny in Zoom, when you open as a presenter, it screws up your other screens. But anyway, I'm here, and let's get started here and see what we can do. I've got this graph here that you probably have seen in the press, and what this shows is just the universe, actually. And the thing I wanted to say about this is most of the radio astronomy stuff we can do, we'll be listening up here pretty close. This is 13 billion years. We'll be in the range of maybe 200 million years, something like that. So that's our signal in our case. And back over here is mostly going to be noise to us. And so that's where we're going to be. This is our home. We're in this galaxy, in the Milky Way galaxy, and we live right here in this arm of it. In radio astronomy, one of the things you got to do is point your antenna at something you want to observe, and maybe they give you coordinates on where that thing is. And this is the system that they use, or one of the systems. There are other coordinate systems that are used, but this is one that's pretty well recognized. And it's essentially looking at it from perspective of the center of the Earth. And the reference point starts on around March the 20th at the equinox period. That's the 0 point, and that's when the Earth is in the middle, I would say. Okay, so you could refer back to this later if you ever are trying to figure out, or something like this, if you're trying to figure out where to point your antenna. So I'll make these slides available to you too later if you want to take a look at them or ask questions or look back at them. You're welcome to email me with any questions later too. But a few terms too are just distance measurements. An astronomical unit, that's the distance from the Earth to the sun. And you'll hear astronomy people talk about that. A parsec is a distance that's established by the distance from the Earth to the sun, and a triangle that you create in this fashion. It's a right triangle. And so that distance right there is a parsec. Okay, in terms of power that you look at, coming from a source that we're going to monitor, that important thing that we want to know about is a Jansky. That's the unit of measure of power coming from an object out there in space. And the way I like to think about it is the number of dB. If you convert it to the dBm of power on a surface area of an antenna that you're operating with, or that has a certain area that it receives energy over some frequency range that you're tuned to or that you're listening over. And so that's how you can relate it back to your radio equipment. Some astronomy folks, when they talk about sources in the sky, will talk about them in thermal units or Kelvin temperature. And that's a continuous emission over all the spectrum. And it really relates to the like the temperature of an object. When it's at a certain temperature, it gives off a certain amount of energy in all the different parts of the spectrum. But we're operating way over on the edge, and so these things have all flattened out by the time we're looking at radio frequencies. But it's a little bit tricky to convert between, but people will try to relate to what the Kelvin temperature is. Okay, some astronomical sources that we might try to listen to or look at. Probably the first one is the sun. It's a star that's the closest to us. And it's got very strong radio signals. And there is a lot of folks out there listening to the sun, and it changes its signal relative to sunspots and things that are happening relating to the sun. And you see reports about the solar activity in QST, for instance, and other places. The moon is not something you're going to listen to a lot, but you're going to see reflections off the moon. Some people try to listen to some of the satellites and the various manned objects that are up there that are transmitting. You might listen to some sort of occultation, or when the moon is blocking something else you're trying to look at in space, so you may be interested in it then. Jupiter is, it does generate some RF that we hear on Earth, and we'll talk about that a little bit more later. The hydrogen clouds is probably the most interesting thing, the place to get started with radio astronomy. And I'm going to go through that some. The thing that a lot of people like to try to do is pulsars. Pulsars are very low level emitters, and to listen to those, you need to have a pretty nice antenna system, usually a large dish of some sort, to get enough energy. Although there are people that are trying to do it with Yagi arrays. And Cygnus A is a radio galaxy that you can listen for. And another area that's kind of new and recent is a giant radio burst, or bursts that are still being studied. These things are signals that are very interesting in the astronomy community right now. And they're very short-lived, but very intense. And I'll give you a little more information about those. One thing to keep in mind is that space is not like a total vacuum. There's dust up there and gases, and some people don't realize it, but if a radio signal originates somewhere deep, far away, it has to travel through these gases and dust and dark energy and gravity, and all these things can affect it. But the end result is that maybe a signal that looks like a spike when it originates gets spread out or has a dispersion. And that is a dead giveaway that it's coming from space if you've got a signal that has that. So you know for sure it's not a local RFI signal. So the Hubble equations, or Hubble constant, talks about how the universe is growing and spreading. And because of that growth, the waves that are coming to us from far away that take a long time to get here are being stretched or redshift or moved in frequency. So you have to keep that in mind when you're doing some observing. Although since we're fairly close, you won't see that much change related to this issue, but just be aware of it. I like this picture I found on the web here, and it illustrates Doppler shift, and you have that in play as we're moving, and we're going to look at some examples of that in a minute. But that can be useful. Some of these things like Doppler shift can be useful as tools to figure out information about things you want to observe or look at. And then I talked about the red shift a little bit earlier. So some things that we can look at are hydrogen gas, large giant clouds of hydrogen gas, masers, variable radio signals that are coming to us, pulsars, supernova, galaxies like the radio galaxy, the sun, and radio occultations and magnetic field effects and calculations. You'll spend a lot of time working on calculations and math in radio astronomy. Software is a big aspect of it. You need your software-defined radio, which is usually your receiver, is going to influence the software that you use. And then each area of radio astronomy will typically have programs that help you with it or contribute to it. You want to collect data. There's programs to help you with that, and the format that you want to save the data in so that you can share it with other people or present it in a way that people are used to seeing it, so that you can relate your observations. And some of the tasks can be done with just a simple Raspberry Pi, like a 3 or 4. Quite a bit of stuff that amateurs are doing these days with those computers. And then I wanted to mention the Python. People that do programming, a lot of them are starting to do some work with Python, and there is a bunch of Python packages that are set up, or libraries, I'll call them, for radio astronomy. And there's a really good series of 4 classes on radio astronomy at this URL that a fellow in the British group put together, and he teaches you Python and radio astronomy sort of at the same time, interfacing Python with stepper motors and other things too as well. So it's a pretty nice to listen through. For equipment, ideally you need a good, some sort of a good reference, local reference oscillator, so that you know for sure your own frequency. And then a GPS discipline clock is ideal, but if not, a computer that's checking the time on the web. So you need to get your timing down as accurately as you can. And an antenna, software-defined radio receiver of some sort, a computer. And what I believe is if you want to try any of this, you need to start with what you have. You don't necessarily need to go out and buy other things, but there are some things you can do with what you have. I'm sure you have something you can do. And so in the rest of my slides, these are the topics I'm going to really focus on. Something called the super SID, which is a sudden ionic disturbance. The Radio Joe project, a hydrogen line, pulsar, fast radio bursts, meteors, and other possibilities. So for super SIDs, the super SID project is a project that's University of Stanford is behind, and Sarah partnered up with them, and we build this small receiver, which is really an amplifier and some filtering that's set up to interface with a computer sound card, and it's listening to essentially low frequencies up to 50 kilohertz. And there are quite a few transmitters that are out there that are transmitting around the world at these very low frequencies. And these are very high power transmitters. And some of these, initially, some of the submarine communication was done by utilizing these frequencies and these transmitters because the energy will pass through the water well. But nowadays, I understand the submarines are not using this, they're using lasers from satellites or something else. But these transmitters are still active. And so as the ionosphere changes, the conditions of these signals will change. And so you can, by monitoring one of these stations, one or more, you can track what's happening in the ionosphere. And there's a lot of people doing this. They're collecting the data with a very simple system and transmitting it back into a database at Stanford. And the Radio Jove system is a little bit similar, except in this case, the frequencies that are being listened to are up around 20 megahertz because Jupiter happens to emits energy due to its strong magnetic field. When storms and things are happening on Jupiter, it creates these signals that can be received on Earth. And so there's this project is to monitor for those signals and collect data relating to them using a software-defined radio again and a special receiver. Now initially they had a receiver that looked much like the one I showed you earlier for SID, but now they're going to a more sophisticated software-defined radio receiver, which has got broader bandwidth. So I believe they're going to utilize this 8 megahertz bandwidth to look at more of the spectrum because signals are coming in spread out over this spectrum. And most of the reception from Jupiter is done during the day. And there's like observing windows when they anticipate that you would see signals from Jupiter. And so again, there's a community of people involved in this, and you can get this receiver as a kit, if you like. And these are the kind of things where you set them up in your yard or in your area there and let them operate and then check them, daily. if you're doing it, it's sort of fun to keep an eye on them. But you don't have to. They'll mostly collect the data and pass it on through the web without your involvement. Okay, for the hydrogen line, it's a case where there's an electron in the hydrogen atom is changing to a different state or a different orbit due to being pushed by collision. And when it does that, it doesn't like being in that state and wants to go back down to its lower state level. And when it does, it gives off energy due to conservation of energy and causes transmission of a radio wave at 1420 or 1.420 gig. And so essentially, if you monitor that frequency and you have a good antenna aimed in the right direction, you can hear this happening. Now, once again, it's because you have these giant cloud formations of this gas. It's mostly hydrogen. It's active. It's causing this emission. So to listen to it, what you need again is an antenna, some sort of an amplifier, a low noise amplifier, a filter for 1420, and some more gain to make up for the filters effects, and then your software defined radio. And this is a system I'll show here down below that's actually been utilized by I'm going to give you some information from some of the guys in Germany, in particular. This guy, Wolfgang Hermann, has done a lot of work in radio astronomy, and he's a pretty prolific relator or educator and published a lot of information. I want to show you some stuff that he has done in particular. But this is done with a 3-meter dish. So it's like one of the satellite dishes that you can pick up. And you can set that dish up stationary. It doesn't have to be on an ASL rotator. It could be in your backyard, just looking straight up in the sky and do this. I put these slides in about GNU radio just to sort of illustrate what one of the things about radio astronomy. This is just a simple model that you can create to generate a signal, and you have a noise source, and you add those two together, and you can monitor it with a spectrum analyzer like the one that's available to you at the meeting tonight. And if you do that, you would find that you have a lot of noise and you have this signal. And I set it up with in the kilohertz. I made a mistake there. I meant to set it up in the gigahertz, but it would do the same thing. And if you do this using an FFT, you're really just converting it to a spectrum analyzer sort of a view, the signal that's coming into you. And then if you average it, you're going to reduce your noise and improve your signal, and you keep increasing your averages. Eventually, you're going to have a really nice view of the signal and not be affected so much by the noise. Now, you can imagine, though, as you increase averaging of an FFT through an FFT algorithm in a computer, that takes more and more computer horsepower. So you have a trade-off of how fast you can sample the signal, how many bits of data that you've got, and how much averaging you do. Now, for the ones of you that are not that adept at all those kinds of details, a lot of this is handled with pre-canned software for you that you can get and not have to deal with the mundane details. But if you're interested in them, you might be able to get more out of it. This is an example of what can be done now. The signal is coming in at 1420, and if you consider this 1420 is like right here in this area. And this is an example of looking at the Milky Way, again with that 3-meter type dish looking straight up in the sky while the Earth is rotating. So this is a single scan to illustrate the kind of radio signal that you would get through the process of that scan. And you see one of these peaks here is lower than the other. And that's, in this case, we're looking at an arm which is like a cloud of gas in that arm in the Milky Way galaxy. And that arm is moving, it's rotating, relative to us, it's rotating towards us or away from us. And due to that rotation, you get the Doppler shift, or the change in frequency of the signal. And so that's why you see a dip in one direction and a peak in the other. So now if we take this graph and we sort of rotate it by 90 degrees and we lay it in here, and we keep doing these scans as we go across the page, we see that we start at 0 and we go up to 24. This is called the right ascension. Well, that's essentially 1 day of scan through that time frame. So these two double peaks, maybe they were right here in this area here, for instance. And you get this graph that shows you the change in velocity of those signals as you scan through them throughout the day. And that's a pretty fascinating thing to do. You can calculate the velocity of the arm in the Milky Way by doing this. Okay, so if you find this interesting and you want to go about this, you can go to this web page, and let's see, this is where I was going to try to switch to this other screen. Yeah, and you'll find that that Wolfgang has created 4 papers on how to do this. And in the paper, he illustrates a bunch of different antenna systems and the kind of performance. And basically, he says in the paper, you can do this with just about any kind of an antenna. He talks about using a dipole and a horn antenna, and then one that looks like this. It's got a bunch of discs on it. It's a Yagi with disc. It's not too hard to construct, but this one here seemed to be the best performer. And it looks like they made wooden blocks and things to support the antenna to hold it. And I saw the picture of his 3-meter dish. It's got bricks holding it up. So he just stacked some bricks in the yard and continued them. So let's see. Oh, it did it to me. I went to the wrong place. I'm sorry. Okay, so he also gives a couple of good talks, and this is one of them on the process of doing it. So let's move on to pulsar observing. This is much more difficult. This would be, if you really want to go after the gusto, you need to, you've got to have a big dish here. I don't know if anybody in your group has already got big dishes. There are some big dishes around you. You can also get access, and I'm going to give you a little bit of information about that later, to other big dish telescopes that are out there. But I wanted you to just understand how this works and what people are doing. Even if you don't ever do it, you might find it fascinating. There's about 2,250 known pulsars today. And what people, radio astronomers, amateur radio astronomers that do this in particular, but even the professionals, is they put together a dish and an antenna and a radio, much like I showed you earlier, start trying to receive a pulsar. And if they receive one, it's like a notch on the gun, you can get that one, let's go to the next one. And they start with the list, start with the strongest pulsar and try to work their way down the list, listening to different pulsars. To do this, what you use is a technique called folding. And that's instead of like averaging FFT signals, you take a scan and then you collect the energy, and you take another scan and you stack them on top of each other. And the idea is that the pulsar is always going to be there, and the noise is going to be varying and jumping around. So what you're trying to do by stacking multiple observations, which is, it's very similar to Fourier transform, but it's not really exactly the same. But by stacking them up, it's going to cause the signal of the pulsar to stand out above the noise. And radio astronomy is really about looking for something that's a signal that's buried in noise a lot of times. The advantage to radio astronomy, though, is the signal is usually pure and consistent. It's not somebody turning on their transmitter and turning it off, or it's not being modulated by sideband or some other signal. It's usually more consistent or continuous tone or a constant wave. And so it makes it more promising in terms of being able to do things like averaging or folding to hear the signal. But there is a package or software program that you can use called Presto. And Presto does all the work for you in terms of listening to the signal and folding. So once again, you need a good time base and a good frequency reference. Pulsars are very stable in terms of their frequency. And this illustrates how this software works. And it shows you the strength of the signal as it folds multiple copies of that scan. And it shows you the dispersion that I talked about earlier. So once again, if you think you've got a pulsar and it may be RFI, you need to take a look at your dispersion plot and be sure you really have some dispersion. And then
When you say a big dish, how big of a dish are you talking about?
well, that's a difficult question to answer, but I'm going to say it needs to be several meters in diameter. But I hesitate about that because it depends on how good a receiver you have and how low noise you can get and what kind of a preamp you have. And they seem to continue to get better and better all the time. And we have available to us a lot of equipment that 20 years ago, people would have just loved to have had. And we can get it for a low amount of money. So I know of a gentleman that's trying to do this with like 2 Yagi antennas stacked in his backyard on a NASL system, and thinks he's actually pulling out a pulsar doing it that way. So I wouldn't discourage you from trying, some Yagi antennas to see if you could make this work. But if you could get access to a larger dish, and I have a 5-meter dish actually that I'm working on putting in place that I hope to do some of this kind of work with myself. You can get information on the strength of the signals that people have seen. And there's a website out there that you can go to that I have a link in here, I believe, later, that you can dial in how much signal strength you have and how much bandwidth you're working with. And it'll calculate the amount of signal that you would get with a given size dish, which is a handy thing to look at for other applications as well. So on this, this is a very nice pulsar, very strong. And the folding also creates, because of the variations it has from scan to scan, this thing they call a bow tie effect, and it has a very nice clean bow tie. So this is the kind of thing, when you run this software and you've done this, you really know you've got it, I guess, when you see this, all the things decorate out properly. Okay, so now let's move on to the fast radio burst. These are very short pulses that are coming from, they think they're coming from magnetars. I remember being at a SARA meeting that normally they're held in Greensboro, not Greensboro, in North Carolina, just a second, West Virginia. And they had a talk being given there by Joe, the guy that won the Nobel Prize. All of a sudden, I can't remember his last name. K1. Anyway, he mentioned fast radio bursts. He started to talk about it, but he decided that it might be too difficult for amateur radio operators to hear it. They were fairly recent things that had been observed at that time.
It was Joe Taylor,
Joe
K1J.
Taylor, that's right. I just had a block. Anyway, now, as people begin to focus on them and realize they were there, they were very short-lived, very strong pulses. People began to look for them more. And as a result, we're finding more and more of them. And sometimes they don't repeat at all, although some of them do repeat. And if they're a repeater, if they continue, then you might see them and hear them every day for some period of time, and then they may stop. And then some time may go by until finally they come back again. And so the one recently was like 20 million Janskis, which is a very strong signal. And so it's at the kind of level that a pretty small, like a TV satellite dish that you can pick up could potentially observe. But the thing is, it's going to require a lot of patience if you do this. But it's kind of like a hole-in-one in golf, I think, in radio astronomy. If you get one and you're an amateur guy and you've heard it, you would really be a big hit in a few circles anyway. So observing online, you can do this as well. If you, the SARA community is working with different groups that make telescopes available, large dish antennas. And this is like a community affair where you have to essentially get on a schedule and have some time on the dish. And you have to learn what you're doing, I guess, to a certain extent, learn what frequencies a dish is capable of hearing and setting it up. And then setting up the program. There's an online application to do all this, but you set it up to listen on the frequencies you want to listen at the coordinates that you want to listen to, and then you collect data, and then you can go away and analyze the data. You could analyze pulsar data, for instance. There are classes that are being taught by people that are involved with these dishes for you to learn from. And SARA actually has blocks of time in some cases. So if you join SARA, which is not very expensive, it helps you be able to get access to them as well. Although you could do it without joining SARA on your own too. And I've got some links here to help you with additional information about that. So these are the dishes or the antennas and things that I've talked about. SARA has they do have a kit as well that you can find on the SARA website that I'll show you a picture of that later, that you can buy. That's sort of like a turnkey thing that'll help get you started doing a little bit of radio astronomy observing. The dish I was just referring to that's online is this 20-meter dish. There's a 40-foot dish at the National Radio Observatory in West Virginia that you can that SARA members get access to, but you have to do that on site. And that dish, you're using actually a strip chart recorder, which is the way a lot of original observing is done. Okay. All right, so now I'm going to talk to you about meteor observing. In this case, it's going to be optical observing, but you can do a combination of radio and optical. But there's a group out there called the Global Meteor Network, and you can set up a meteor camera at your home, and with a fairly low cost camera that's available, $38. Went too fast here. And it's got very good low light sensitivity. Actually, the camera, when it comes to you, it has a filter in it that can switch like a daylight dark filter that switches back and forth. And the first thing you do is take that filter out, get it out of the way, because you don't use the camera for the daylight part anyway, and it doesn't hurt it to be overexposed. We're running it at less resolution than it's capable of, just to reduce the amount of data. When I say there's a software package that's pre-configured and ready to go to do all this work for you. It utilizes a Raspberry Pi 4 on a you want a larger SD card, because you're going to save this data to the SD card. And you could also use another low cost, like an i5 based Intel type computer. I found will work as well. And the builds and things for this are there, or you can get the SD card pre-built if you're not. And this is all mostly done in Linux. If you're not a Linux person, you can get this pre-built software. This is a picture of what the camera looks like. That's about a 2-inch square PC board. That it's taking about 6 weeks to get these from China these days. And you can buy the like a case for it that looks like something you'd see at a security camera, and put this camera inside of it. So from this point of view, it's sort of like a kit. You do have to do some assembly, but it's not very difficult to do. And there's a lot of guides out there to tell you how to do it. And these links will take you to those guides, show you this as well. And if you set this up, this is an example of what I saw. I've got this observing every single night. And this is the Perseids meteor shower, which was peaking around August timeframe. And you see this night, I think I saw 52 meteors overnight. This is like a composite where all the frames that had meteors in them have been stacked. And so this is like star trails from the Earth rotating. So this star is just moving through the course of the night, and these meteors come streaking in. Now this when you see these flashes like that, that's an airplane, not a meteor. And you can see bugs flying here sometime, or bats, other objects that can cause us problems. But the software is really nice. That's looking for these meteors. It's looking at the velocity. And ideally, what we want is to have multiple people with cameras. The software will backtrack the path of that meteor and show you the place that it originates from. And it's like the meteor shower. Like this is the Perseids meteor group here. And so all these are the meteors that showed up in my view that night.
So sorry, does this mean that, Mark, should I climb the tower and put one of these at the top of the tower facing up?
No, you shouldn't do that. I'm not
No?
Mark.
Well, I was talking to our technical chair.
Yeah.
No, you can do it from ground level. Another 60 feet probably won't matter that much.
Well, the problem with the tower is vibrations or movement, I think. I ran into that trouble. I put it up on a tower sort of myself, and it had more vibration in it than I realized, which isn't a problem for radio amateurs.
Thinking getting it up above the tree line.
Yeah, you need to, ideally you want to do that. You can work around the trees to some extent.
Oh, this is not an amateur radio tower. This is a massive tower.
Okay.
But still, we probably best put it on the cinder block building.
Yeah.
If the club is interested in doing this, quite frankly, we've got a dark sky site about 5 miles from the Mount Palomar Hail Scope, operated by MIT. So we've got a good site.
And if they have an internet link there, that's really great. If you got a way
I just added it.
Okay, well, that's nice. But you see this plot down across the bottom, it shows you all the different meteor groupings, and you can go back and track these 3-letter acronyms to understand what they are. And this is the line as we're moving through the course of the year. And for instance, this is just this recent, a few days ago, and I still had like 9. I get quite a few meteors almost every night. And I was just amazed at how many meteors are shooting at us. That are coming through, and those fireballs are pretty regular too. And this is another more exotic example of a fireball that was captured by a group in New Mexico. You see they get pretty bright. Most of these burn out in the sky before they make it down. This is an airplane flying by. I'm thinking the guy that was flying that thing was pretty well watching what was going on. And unless it was behind him. This is a fella in the UK. The UK has the best network in the world right now, I think. But he's got 6 cameras here, and this is a composite showing the view of essentially his whole night sky. But you can see these houses and things that he's looking over. You can see the trees that are in his area. So you don't have to get above the tree line. You're going to get a bigger field of view if you do. You've got to make decisions about, for instance, you can buy different angular lenses, so you can get a wide angle or a narrow lens. And the wider ones are more popular to get a larger view. But ideally, you'll have multiple cameras, not at the same location, but in different places, because you need to get 2 cameras to get the trajectory down and calculate where the meteor is going, and they follow them all the way to the ground. I'm going to show you another slide of that in just a minute. But this is I just want to show you some of the depth of the software here. This is a star chart showing you the stars that were visible at night, and the ones with circles around them are the ones that are being used to calibrate the camera. And you build these, they call them a plate pair. You set this up initially, and there are people that will help you do this to sort of get your camera calibrated after you put it in place. And after you have it, this is an example of through the course of the night, the field of view of the camera is drifting around due to thermal things and movement in the camera, potentially. Mainly, I'm not sure all of the mechanisms that are causing this are understood, but this just a plot to show you how much error you have. This is this illustrates the correction of your lens. So these are inexpensive plastic molded lenses that have aberrations and things in them that by using those stars, you can correct for. And in the software, you can get all that out of the lens or most of it. And this shows you the variation from the part that was corrected or not. Okay, and this is looking at the light intensity from the various stars and calibrating that intensity. And so it's showing you that variation. And what I think is interesting about this, these guys are mostly interested in the meteors and the meteor tracking. But now that you've got stars, you could also do variable star studies, for instance. You'd have to generate more software yourself, but you could have a nightly collection of star brightness and look for variable stars in your field of view. All right, this is tracking the meteor to the ground example. This is again in the software package, and it was following a particular fireball that came in the UK, and they've got a bunch of different graphs that were created, but it shows you right up here this little line that the thing ended up in the water. Most of these things end up in the water because the earth is mostly water, but it was very close to hitting the ground. And if it hits the ground, they can calculate where it's going to hit within a very small area, like a few hundred yards. So you can go there and look for fragments or potentially what's left of the meteor that came in. Meteors, a lot of these are just dust particles too. They're not necessarily real large. but some of the ones that are fireballs are definitely larger. The software will tell you approximately how large the meteor was, what it weighed, and some other information about it too. It's pretty fascinating. These are cameras in the US, and I grabbed this because it includes more or less your area, and it looks like there are quite a few people that are operating in your area. The more people you can get to operate in a particular area, the better chance you're going to have of actually triangulating the meteor and figuring out where it went. So I'm thinking that you're in this area. This is probably a little bit like a disease. When people hear about it and see it, they think they got to do it. And so probably these numbers will grow out from this area here, the center. So other things you can do are, there's a thing called HARP, which is really pushed by a fellow up in Alaska, that they're transmitting a large power frequency and looking for reflections off the atmosphere and the moon. And this is where you could just tune in with your HF radio. You can look at the Earth's magnetic flux changes, mostly due to the sun. And there's a group that Whittam Reeves is the guy in Alaska that's doing the HARP. He's working with the HARP group, I should say. But he's also got a magnetic flux monitoring thing. And this monitoring the magnetic flux of the Earth is hard because it's down around 50 milliteslas, which is a very low level magnetic field. And Tapper in the Tangerine Project is building a board that will let you do this. This is the kind of thing where if you get this board and you hook it up to your computer and you're going to bury this probe in your yard about a couple of feet down in the ground to get temperature stability, then you can just let it collect data and transmit data back to the central station. And it's pretty fascinating to see how much the magnetic field of the Earth is changing. The British group is also pretty active in this area. And then there is a guy, a couple of people in the Sarah group doing masers with a 12 gig dish. So he's using, I believe, satellite surplus stuff that he's not spending a lot of money to set this up. And most of these radio astronomy projects are study it from a scientific point of view, figure out what you think you might be interested in, and then get the stuff together, put it in place, and let it collect data, and just study it when you have time and see what kind of results you're getting, but usually over a longer period of time before you really are excited about your results. You could do interferometry type projects, which means you're going to have two receivers or two antenna systems separated by some distance, and that there it's in my mind it's more important to keep track of the timing signal very close so that you can correlate the data. There are people that will argue that, think that they can take the data and move one of the two stations and make them overlap, but that's a more advanced thing to try to do. You can join Sarah for 20 bucks, $10 more if you want to get access to the journal through Dropbox, but it comes out in the mail if you just capture it under normal times. There's a couple of conferences that happen a year that quite a few people go to, in the range of 50 to 100, I'll say. One of them is called the Western Conference. And that conference they're talking about holding it in Owens Valley near Big Pine Bishop, so not so far from you guys. And if that happens, it would be in the March timeframe. We're still trying to decide and set that up. And, you know, those are difficult to do, to get the hotel space and everything worked out. The Eastern Conference is normally at Green Bank, West Virginia. It's a little bit difficult to get to because it's a radio quiet zone in the middle of the mountains, but it's a very pretty place to go to, and that's in the summertime. And usually you get to go and take a tour of the dishes and maybe go in them, and you go in the rooms where they're operating the dishes. I've been there a couple of times, and essentially got free reign of the radio room, and I could go in and run software and do things on the computers there, not really steering the dish or anything like that. It's parked, but you can do experiments with pre-collected data. And then the VLB is another thing that you can get access to different VLB facilities. Once again, there's groups within SARA that are studying how to utilize these radio dishes and the data from them, and you can get the data. There's a lot of data being collected that is going unused, I would say, that you could, and you know, this is scientific stuff where you could, if you're willing to put some time in and you have the right mind, you could potentially come up with some kind of a thing that other people hadn't found or realized. There's a nice web page you can go to on SARA that has got all these different tabs up here across the top that take you to very interesting things. The recent Eastern Conference, there's a bunch of YouTube videos that you can listen to about a lot of the things that I've just talked about. I find these a good thing to do, like if you're riding an exercise bike or something like that, you can listen to them, encourage you to get some exercise. Most hams need more exercise, I believe. So I encourage that kind of a thing. This or podcast would do either one. This is the scope in the box you can buy from SARA and the Super SID project thing. And those are the kind of prices to get it. Get you started. That's in the store on the SARA webpage. There's a very active email group that there's some really, really sharp people involved in SARA. You can, if you have problems or don't understand something, you can post questions about it. See the HARP listed there. That's because they're recently doing some large transmissions that looking for reflections off the moon from that. And these are the kind of things where they do this transmission and they're hoping for citizen science people like ourselves to listen and give reports on what you heard. And it's a short-term thing. It happens and you have to be there and hear it, report what you heard, and it's over. Maybe until the next one, some months away. There are several Zoom meetings you can attend. There's something called Drake's Lounge, which is a lounge at West Virginia, but they have a Zoom meeting that once a month, and an RTOP, which usually at that meeting, there's somebody reviews their radio astronomy project and how they did it and what they're doing and how it's working out. There's one about to begin with some guys in Australia. There's an active astronomy group down there. Normally all these meetings up here have some participants internationally too. And a couple of those people, again, are very, very knowledgeable in astronomy, either retired from working full-time in astronomy or in some other area, but were closely associated with astronomy. And we have some outreach programs as well, where we have grants that are offered to people that want to apply for them, and we're giving money to help teachers. And there are projects and things that are put together to help teachers and brochures if you're a teacher or would find that kind of thing interesting. And that's a tab on the web page that has a lot more detail available. I would encourage you to go take a look at that. And you should go see these these things that mostly were done by Wolfgang, YouTube videos that tell you the process that he used and what was done. Like this fast radio burst thing was very short, very interesting talk. Anyway, it's amazing how much you can get out of YouTube these days. So that's my slides that I put together for you, and I can answer hopefully any questions you might have.
So I have a question.
Okay.
This is AI6RR. So the Arecibo telescope, that's a radio telescope, correct?
Yes.
And do they actually aim at, or do they just take whatever's in front of them as the Earth rotates? How did that work?
Well, unfortunately, that telescope had a catastrophe and
Right.
they did aim it. They did aim it. And the way they aimed it was they had this, you can think of it as the feed in the feed horn of a dish, but it was a little house that was suspended by cables and you could move that around. And so by doing that, you had some ability to make a change in the way that dish is pointed. And that's how they were aiming the dish. Well, that's what fell into the dish. And
Looked it all out.
unfortunately, it was hard to get money in a lot of things like this these days. And so I'm not sure where that stands. There's a lot of in my mind, there's a lot of competition in the world for astronomy and radio astronomy. Like the Chinese have a very large radio astronomy dish that came online fairly recently. Arecibo was built in sort of the bowl of like a hill, and I think the Chinese were as well. There are other places in the world that have large dishes, like at the National Radio Astronomy, or not the one in West Virginia has a dish that is 100 meters in diameter. It's movable and steerable, and that's a pretty big feat in itself to move all that steel. There's one about that big in Germany. So some of these much larger radio dishes are coming online too, or not dishes, but
Arrays.
combinations of dishes, you know.
They're doing more like an array of several dishes, like the Hubble, not the James Webb telescope, multiple dishes that focus.
Yes, yeah, they're going to compete with the James Webb, but almost everything that's being done has a little bit of a different niche or different wavelength that it's looking at or capability. So they complement each other. And if one of them sees something, they all want the others to go take a look too, and they can make a composite of what they've seen. So there is a large radio telescope project underway too that's going to be in Nevada that is currently planned for Nevada. It'll be a very large collection of radio dishes that are going to collect data and make it available to the public. It'll all be open source science type projects. And it's kind of like a camera taking pictures at different radio frequencies in the sky. And it'll be voluminous amounts of data though that you'll, if you got interested in that and want to participate, but you could take a segment of it. But what's nice about all this is you can find data. If you start trying to do radio astronomy yourself, you can find some other data online that you can compare your data with to get yourself calibrated or validate something that you're doing.
Well, Bob, if you don't mind, this is KF6WTN. I'd like to make a quick little announcement here, both to our club and to you. And that is that our repeater site that our club uses primarily now just for regular old 2 meter, 440, 6 meter, 220, whatever, that kind of stuff, is at 5,300 feet on the top of Mount Palomar in the dark sky area, only a few miles from the 200-inch Hale telescope that's used by Caltech for doing a lot of the optical research. So we've got a fantastic site. I just got a good quality internet link to it. So, and our charter is to support amateur radio. So if you need a good dark sky spot with some trees around it, we're in a national forest, so can't cut down the trees, sorry. But we've got stable battery backup, huge battery array. If you need to put some experiments, we're always looking for something interesting to do. Now, having said that to you, a general comment to our club, we are starting what we're calling the PARC Modernization Program. The modernization program, among other things, I'm building a small rack area in the main repeater building with slots for 8 SDR experiments. This hasn't been announced yet. It will be announced hopefully in the next couple of months. But we're putting in support facilities for people to do their own SDR work up on the mountain. And antennas for that are still up for discussion as to what people need, what bands they want to work in, so on and so forth. And needless to say, they get access to that internet link. So Bob, if you want something to work on, you've got some West Coast friends out here.
Okay, well, that's nice. Thank you. And keep that in mind. I would encourage you to take a look at there's a software package called SDR Angel. I don't know if you've looked at it, but it's a more complex package to use, I guess. But you can build it, or you can find pre-built versions that run on Linux. And one of the things that they do in there in that package is they look at different repeaters or monitor them. So you could set up one of those in one of your radios that jumps around and listens to all your repeaters and keeps track of their performance, for instance.
Yeah, actually, I'm currently sitting at my lab bench, and I just retuned the spectrum analyzer. I've got a peak at 1.4200002 gigahertz. It's about 4 dB above my noise floor because I'm using a broadband antenna and no preamp. I may hook in a preamp after the meeting.
Okay.
So I found your hydrogen emissions. I figured I'd go for something easy.
Okay.
But right outside my window is a 3-meter dish that I'm not using right at the moment. So that's why I was asking you, how big does the antenna have to be?
Well, you can certainly do some things with that antenna. Like I showed you earlier, that work was being done with a 3-meter dish. So
Well,
that's
I've got
pretty
a
nice.
pair of LNBs out in that dish right now that block convert 1 gigahertz wide swatches at 4 gigahertz and 12, but I can adjust the frequencies. So
we had 2 comments from the room. One of them was right before Mark started talking about, hey, we have dark sky. It was basically the same thing. Hey, let's put this on the mountain. So we're all on the same page there. This would be pretty cool. And then the other was a question for Bob. Have you, or has anybody that you know of heard, seen anything interesting or unusual in your view of the sky radiographically?
Yeah, I would say that people have that. The thing is that is the fast radio burst, and this fellow Wolfgang frequently lately has come to our discussions and reported one that he just heard that are being put out in what's called an astronomy telegram to the world, essentially reporting that he's hearing it. And these are the kind of things where somebody reports it and then other people follow up on it to see if they can duplicate his results. And so, yeah, that's the most exciting thing I would say that's happened lately.
Okay, and then I've been seeing, this is probably a little bit outside of what we're talking about right now, but I've been seeing that the Voyager probes that have left the known space and they're in interstellar space now are hearing some interesting things and sending back some telemetry that the scientists at NASA are questioning what's going on. Is that something that's being followed by the groups that you're involved in?
I have not heard anything about that, although I'm not surprised to hear what you're saying. There are a lot of things that do come up that are signals that can't be identified. That it's kind of like the original pulsar was found was labeled a little green man #1. So there could be things out there, we just don't know. That's one of the things that's exciting about space. There's a lot of discoveries yet to be made, and as we kind of marched along through time, like I showed you that first picture of was of the universe, and that's kind of like the conception of what people think it is based on what's known today. that whole thing could change, and in the next 10 years, they could redraw that and say, no, we were wrong about this and that, and here's what we really think now. And it's a continuous evolution of understanding space, essentially.
Yes, and we can't talk about the galaxy without the famous Douglas Adams. Far out in the uncharted backwaters of the unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun. Orbiting this at a distance of roughly 92 million miles is an utterly insignificant little blue-green planet whose ape-descended life forms are so amazingly primitive that they still think digital watches are a pretty neat idea. Yes, I had to read it. Sorry, I didn't have the whole thing memorized.
Yeah, I was impressed. I thought you were doing that from memory.
I probably had most of it memorized, but I didn't want to, flub it and on the recorded Zoom.
Yeah, and that in itself is kind of sad.
I can interject one more thing that's along these lines. It's off the radio astronomy thing, but you mentioned you were having trouble with mice up there in your site. I have a ranch here, and I've got several barns, and I'm always trying to figure out how to get rid of mice. And there is a device you can buy out there on the internet. And it's a noise maker at frequencies just above the audible level of a human. But I found out that mice can hear like almost up to 50 kilohertz. And so you turn this thing on and it drives them crazy, and they get out of the area. Some of them don't, though some seem to like it, which is weird. But I also found out that cows can hear at a very high frequency. And so I'm wondering, I've always wondered, how do the cows communicate with each other and and other animals let each other know? There may be a whole bunch of communications going on that we don't know about, that even in outer space that eventually in time we may be able to understand, hopefully.
Well, I have several acres where I am, and I've used the ultrasonic pest repellers, and I found the same thing. It repels some of them, and some of them seem to like it. So I've gone back to good old glue traps and bait stations.
Right.
But the one little mouse up on the mountain in the battery bank room that ate through that aluminum screen, I don't want to meet him in a dark alley anywhere. He has to be a tough little mouse.
Yeah.
Unfortunately, he was setting up his residence right on top of the 48-volt power supply that keeps the battery bank charged.
Nice warm spot. Yeah.
Yep. So I evicted him, vacuumed the area off. And when I went back to check last week, he hadn't been back. So I'm keeping my fingers crossed, because I can't afford to lose. That's a single point of failure, is that power supply.
Usually
I've got other power supplies.
They'll chew into wires usually, and so you need to get some wrap and put around the wires. In case
Yeah, I've got spiral wrap.
Spiral wrap, right?
Yep, I've got spiral wrap.
Yeah, I recently had to do that to my hot tub.
Right.
Anybody thought about cats?
Unfortunately, I've got enough coyotes up here that my last friend who had cats gave up naming them and just assigned them numbers. And I'm not quite cold-blooded enough to do that.
Yeah.
All right. Are there any other questions for Bob or for the group in general?
Well, like I said, Bob, we've got a beautiful spot and room to support experiments. Keep in touch, please.
Okay, I'll pass that along to some of the folks too. Come join Sarah. We'd love to have you.
Yeah, and if you send
Well,
that, send the deck to me on the email thread we're on, and I'll make sure that gets over to Keith for the scope. So you can the members can look for that in next month's scope article. And then next month's meeting is the social. I don't think we're going to do anything on Zoom next month, because social is kind of like it's being social in person. And bring some sweets, come meet at the facility here, and we'll have our election, and that'll be the December meeting, and then we'll get on to planning 2023.
And like I said, because I'm one of the advertisers for it, so bring your radios, bring your antennas. Anybody who made those projects, like I said today, I didn't show. I did the offset attenuator kit, so I'll have it in a box by the time the meeting is. We'll test the offset attenuators. So bring all your toys and food and your appetite.
Good. Thank you again, Bob, for this very informative presentation. I really look forward to hopefully getting some radio astronomy up on the mountain. That'd be neat.
Hey,
Thank
All
you.
right.
We've got a great sky for that comet tracking also.
Oh, yeah. Okay. Thanks, everybody. Good night.
Night all.